Hello, SYSC 4609ers. Introduction to Data Science. This is basically an asynchronous lecture from yours truly, TA for this course. My name's Kevin Dick. This slide here is going to basically cover the slide set. We'll basically cover everything we'll go over in this kind of tutorial, but also just general introduction to what is LaTeX, a typesetting type of program that I'm hoping everyone in this course will start to become familiar with if you're not already. So yeah, this should be about a 30 to 40 minute introductory tutorial on both the history and how to use LaTeX for preparing various types of documents. Some of you might know me from SYSC 4906 that was offered in the fall semester, the Introduction to Machine Learning course. If you've taken that course with me as a TA before, you'll probably recognize this generally similar style of presentation. Basically, I'll just go over the history of stuff and then we'll jump into what's basically a dynamic or like, it's not really interactive because this is asynchronous, but I'll just basically demonstrate how you can generate LaTeX documents that will likely be used and hopefully be used for your project proposals in the course and also for the final reports. So without further ado, before getting too deep into anything LaTeXian, I'll just introduce who I am, what I do. I'm the TA for this course. So I'm hoping I'll give you guys a good idea as to what kind of experience I've had with data science in the past and just artificial intelligence and machine learning in general. Those are my domains of expertise. So my background is essentially in biology and computer science. I did my bachelor's at McGill University and ending in about 2014. Thereafter, I worked for Revision Military, now known as Galvion, in Ottawa. And I started my master's, I think it was in 2016 at Carleton. I then fast-tracked to a PhD, which is what I'm completing now. As I mentioned, in the fall 2020, I was a TA for the same course code, but Introduction to Machine Learning instead. And you'll probably get an idea as this semester kind of goes on. I have a pretty broad set of expertise and interests. I work in quite a few different domains. Predominantly, I work in pairwise prediction. So bioinformatics in particular, my research is predominantly in the prediction of pairwise relationships as they relate to bioinformatics. So things like protein-protein interactions, trying to predict which ones will actually interact together. This can also relate in some ways to network science, which is a pretty large and broad subdomain of data science as well. And then in a complete kind of shift away from all that, I also work in computer vision for a number of applications, but predominantly in autonomous vehicle informatics. So as a result of a number of different grants that we were able to apply for over the course of the last 3 to 4 years, there's an entire subfield of research that I work in on basically using imagery derived from autonomous vehicles or like camera instrumented vehicles to study various phenomena in the natural environment. I'm also, I have some expertise in natural language processing, more as it relates to another complete subset of research that is actually more related to quantitative criminology with a couple of collaborators at a few different universities. And through it all, I've actually done a lot of work in web service development, just creating tools for use by the research community or for various types of applications. I have some experience in working in chaotic dynamical systems, or like what's known as like chaos theory. That was very popular in like the 1980s, but how it's kind of being refreshed in this new day and age through the use of convolutional neural networks and various types of kind of modern algorithms. It's kind of seeing a resurgence. And I have some basic expertise in like signal processing, working with a few collaborators on audio data right now for a number of different projects. But yeah, in general, you'll know of me probably over the course of the semester as being someone who's got my hands kind of in a number of different applications, and I'm hoping that depending on how the projects work out for this course, I'll hopefully have some opportunity to kind of guide you along in what your own projects will look like. A lot of this has to do with just data science, machine learning, AI in general. And so anyways, I left a couple of just links to different things that I've worked on before, like my website, my LinkedIn, my GitHub repositories. And yeah, so I work actually as most of this is branded with the Carleton University Biomedical Informatics Collaboratory. Basically, Dr. James Green's lab. We call it Cubic for short, but yeah, in general, I work in a number of different things. So I'll just kind of maybe list a number of projects just to give you guys an idea of what I work on. So our most recent work was actually just generating predictions for COVID-19. So we have a few papers on this front, just trying to come up with potential targets for therapeutics. Those of you who are in the SYSC 4906 class, you'll note that some of the results from that course on the domain of drug target interaction prediction, so trying to figure out what kind of small molecules, what kind of drugs in general can be repurposed as candidates to basically reduce the symptoms of COVID-19. So that was basically the course project there. So for those of you who contributed to that work, you'll probably hear from me in the next couple of weeks, just touching base on that again. That was all stemmed from work that was done in 2016 that was looking at the Zika virus when it was kind of resurging through Latin America. So I did some research trying to predict targets for that, as well as the malaria virus. I got to spend a few months in India, actually working with collaborators who studied the malaria parasite, so Plasmodium falciparum, basically just collaborating with them to come up with candidate targets. And then I've done a number of just general other types of projects, mostly around trying to figure out where it is on a certain protein that you know, a given drug or a given interaction might occur. So comparison of protein sequence and structure based methods. Chaos game representation is what I was alluding to earlier, this idea that chaotic dynamical systems can be used for a number of different tasks. There's a fourth year project that I'm overseeing right now that looks at the actual protein site of interaction, trying to figure out where it is on a given protein that things interact. And then way back when I was working on other like human proteome, personalized interactome type things. A lot of it is just like very molecular biology based, but in general, it's just how can you use AI tools and machine learning to basically understand these complex systems in the first place. So that's my like main research area. But then I work in these as well. So as I was mentioning in autonomous vehicle informatics, one of our first papers was basically just trying to explain how deep learning can be used for a number of different ways of studying the natural environment and how we can actually like secure and protect critical infrastructures. This was done in collaboration with Natural Resources Canada. And then there's other work that is kind of going through the pipeline right now, just on trying to compare different types of methods. There's this kind of computer vision technique called keystone correction that we're looking to evaluate for a number of different applications. And then one that is particularly interesting is, can we just like automatically read and extract gas prices from autonomous vehicle sourced imagery? So this is kind of ongoing work with a number of collaborators, as I had mentioned, at the University of Toronto and University of Winnipeg. We're looking to use NLP, like the latest NLP-based methods, to measure things like judicial bias. So whether within court documents, you can actually determine whether there's like systemic racism or discrimination against certain subpopulations based on things that we can extract from those documents themselves. And can we measure this in a quantifiable way is one avenue. Another is just measuring something like the degree of document redaction, how much information is actually being kind of like, well, not shared, but being like retained or well, redacted from public view by different departments in legal systems. So there's a lot of like interesting studies that you can do as soon as you get your hands on like large scale sets of data. So these are all, maybe they'll start triggering certain ideas that you might have yourselves, depending on how we formulate the projects later on in the course. But the idea is to kind of like think about how different types of tools and technologies can be used depending on the data that you have available to you. And then there's a number of like miscellaneous projects. So I did a chaos game representation for protein type applications with another set of collaborators. We're trying to do this also for audio signals, which is interesting. We can use that as a representation to try and classify between different types of sounds. My own data science project for the graduate level course that I took back in 2016 was actually on trying to identify individuals within Canada who are unlikely to be vaccinated, which is particularly interesting in the context that we're living through now, because anti-vaccination sentiment is actually a very dangerous and like critical like school of thought in this current COVID-19 pandemic. So yeah, the project there was just using like StatsCan data to try and figure out what kind of behaviors are correlated with anti-vaccination sentiments in general. So that was a particularly interesting project then, and a particularly interesting one now. Maybe something to think on for any aspiring or like motivated groups for this course. And then just general like web service development, as I had mentioned before. So I created a web system to basically improve data set quality for different types of tasks, predominantly in molecular biological context. But these are always like valuable types of invested time into projects to develop something that's actually like very readily usable by the general research communities and otherwise. And then just like deep learning models for different types of tasks. We did one on tongue classification for different types of speech therapies, which is an interesting application as well. So without further ado, let's actually jump into what LaTeX is, what this is all really about. This is basically just like a brief history. So what LaTeX is, and you'll see this like little bit here on like the pronunciation, it's LaTeX, not latex or LaTeX sometimes, and it's usually stylized in this way with these kind of like offset characters. So it's basically a software system to actually prepare documents. So the design philosophy that kind of is at the foundation of it is to really separate presentation from content. So authors shouldn't be required to like visually tweak and modify information or like text or images or whatever it is within the documents themselves. They should focus only on creating and generating the content without having to attend to simultaneously how it actually appears in the document. So LaTeX as a system tries to kind of really take away all the like nitty gritty details of having to like lay something out beautifully. All you have to do is generate content and it will do it for you. So it's kind of different from SYSC, like what you see is what you get, things like Microsoft Word. And what it allows you to do is actually define like global parameters or global types of settings or representations. And this is very similar to those of you who are familiar with other types of markup languages. So like Markdown basically has certain sets of characters and types of markup that you can use to basically specify how something will basically appear. So all you have to do is just like add those characters and it stylizes it for you. And that's also very similar to things like CSS that is used to style HTML documents, and just like kind of set these variables or these kinds of like markup tags, basically like starter ender tags within a document. And it doesn't really matter what you do after the fact, you just generate the content and it appears as it should. So into like kind of how LaTeX itself became about, those of you in more of the computer science or computing fields will probably know the name Donald Knuth as basically like the forefather of the analysis of algorithms. He wrote this like 4-volume textbook or set of textbooks that's known as The Art of Computer Programming. So it basically was born out of that initiative. He published his first volume in 1969 and used what was at the time this like monotype way of like basically representing the textbook itself under this like good classic style, which he appreciated a lot and thought it represented the textbook really well. But then what happened shortly thereafter was when he was going to publish volume 2 in 1976, The typesetting system. So typesetting is just like the way that you take a document and you prepare it in this like formal way to have it like sent off to the printing presses or the printers to have it turned into an actual document. Basically, just like taking the information and turning it into what becomes the book or the textbook thereafter. So in 1976, all the typesetting systems had kind of shifted to this like photography-based technique, and all the fonts and the layout and everything that he appreciated in the previous like iteration, or like the first iteration of his volumes, were no longer available. So as soon as he received the proofs for the second version, he thought they were absolutely terrible. And that really like triggered with him this like interest in digital typography. So typography again is just like similar to typesetting, is just like how do you like organize your well, typography itself is how do you like generate fonts and whatnot to actually represent the content. But this really triggered with him this like entire initiative to come up with his own typesetting system. So he actually spent basically what was to be a decade creating this typesetting system. So it ends up at the basis of what the LaTeX typesetting systems are today. He meant to spend like a sabbatical year, so like the 1 year like free of most teaching commitments to actually prepare this thing. And it ended up like dragging on for about 10 years in time, but really established the foundation of what is now this very powerful typesetting system that is used very broadly throughout the world. So why should you actually learn LaTeX is usually a good question. So the first is that it's actually very heavily used in a certain subsets of fields. Those again with like computer science, predominantly in artificial intelligence and machine learning. Data science is a bit of a weird like kind of catch-all term. Like there is artificial intelligence and machine learning at the basis of data scientific systems. And certain data science journals will use LaTeX documents and like templates into account. But really like artificial intelligence, machine learning, and anything that's like physics, math, or heavily computation-based fields. So things like computational psychology or computational neuroscience, computational chemistry, most of these fields will really heavily use LaTeX. So if you haven't been exposed to it yet, this is a really good opportunity, at least within this course, to at least gain some familiarity with it. And I'll also introduce maybe like in the next slide, these other kind of like more creative uses that you could have out of LaTeX that could actually benefit hopefully you and whatever organizations you might like go on to work for like later on in the future. There's a lot of opportunity to use LaTeX in like very creative ways depending on where you end up. So the other thing is LaTeX is Turing complete. So for those of you who are familiar with Turing completeness, you might realize that this is actually a pretty cool concept, that a typesetting system can be used to like actually program just about anything. And to like basically introduce a few more like esoteric examples. So within LaTeX systems themselves, you can create something like the Mendelbrot set. For those who aren't familiar with the Mendelbrot set, it's like a fractal computational pattern. I'll like show what that looks like here if this comes up. So basically you can just, create these like counters and whatnot. This is going to be a bit far from what you will be used to looking at yourselves, but basically within this like short 50 or so lines themselves in this like small document, you can actually generate a character-based representation of what is the Mendelbrot set, a fractal-based representation of the complex plane. Just like it just goes to show what the extents of this system can be. You can create a Turing machine in LaTeX. So these are all links. I'll like share the slides within See You Learn Later, but basically you can read along about how somebody actually created an entire Turing machine using LaTeX alone. And then there's this really interesting example that I didn't even really know about until I was researching this, but LaTeX was actually used in a programming contest. So a Mars rover controller was actually implemented in LaTeX, and it actually beat out in 2008 several other more common programming languages. So it's probably nothing that you'll want to implement yourselves in your life or like use as an actual programming language, but it does go to show how like powerful or complex this system can be. But on the other hand, for those of you who might be familiar with this XKCD comment or comic, Turing completeness doesn't necessarily always mean that the system itself is robust. So I'll let you guys maybe like appreciate this comment on, or this comic on your own, but it basically boils down. There's this like very specific part where it talks about rocks in this, like setting rocks and moving rocks in different rows, given infinite rocks, infinite space, and infinite time. You can actually create a Turing complete system. So it's a pretty like nice touch on a few different things, but it basically talks about how rocks are used to simulate a universe. Just kind of like a fun example to throw in amongst the rest. But again, this is just like general demonstration on how this can be used for other types of applications. But really what you guys will need to know about this is or about LaTeX itself is just how to like prepare nice and good looking documents. So there's a certain set of applications where it's particularly useful for. So say, for example, you need to consistently format not just dozens, perhaps hundreds or thousands of documents or reports. Ideally, you would be able to set up some kind of system where you could just, outline what the format with the layout should look like. And then you can just kind of like set up this like programmatic loop that just like grabs content and just dumps it into this this LaTeX system to format everything. So one example of that, I was an editor and a layout officer, like associate for this graduate run journal called the Health Science Inquiry. And so just as an example, because we needed to lay out all the documents themselves systematically, I was able to just like create this layout of a nice looking article that you would basically just fill in the information, and it speeds up the process of turning into this nice thing. Instead of taking like 50 or so articles and doing this all by hand, you just copy and paste all the data in, or just grab with like a looped programmatic with a programmatic loop, you just grab the text from here and put it into the right place, and then you just compile the document, and it spits out the PDF in exactly the format that you expected. So there's a lot of advantages when you need to generate a lot of documents that look the same. And then there's this other really interesting application where if you need to create multiple versions of the same document, because it's Turing complete and there are like if statements and conditional statements that you can include, you can really control what you want to appear or not appear depending on just setting a few different variables. So one example would be, say you're creating a resume, you want to apply for a number of different jobs, but some jobs require a 1-page resume, others require would allow for a 2-page resume, and others for like a 3+ page resume. What you could do is you could basically set different sections of your resume to appear or not appear depending on whether it's a 1-page, a 2-page, or a 3-page. So you just change this one variable, you recompile the document, and only those sections that appear within that if condition, it'll generate the document as a result. So it's this really neat way to control how you can represent, basically the same information, but in just different layouts and different formats in general. So anyone who's like interested in trying to set something up along those lines, like please feel free to like email me or whatever. There's like some really cool applications that you can do. And you can imagine this could be kind of useful for different organizations themselves. Like say, you're at some company and they have all this like information, all this text represented in some data repository, and they want them, generated into this like report format to send off to apply for some kind of grant or some kind of application for funding or whatever it might be. And instead of having someone spend hundreds of hours copy pasting and formatting, you can just set up this LaTeX file and then just programmatically generate all these reports automatically. So there's a number of interesting creative applications. The other and the final is you can use this to like generate what I like to think of as like personal or just like consistent branding of your own documents. So surprise, like this entire slide set that I'm sharing with you is actually made in LaTeX. And again, those who are in my in the SYSC 4906 fall semester course will recognize this slide set. That's just like, it's just a standard that I've put together, and all I do is just put in new content, new slides, and I can generate basically new slide sets as a result. So now we'll actually jump into the part where we actually demonstrate how to use and how to prepare these things. Overleaf, so this is basically a cloud-based like LaTeX document preparation system, is what we'll use to go to basically demonstrate some of these things. I mean, this is just their logo. We'll look over basically the gallery of different templates that are available for a number of different types of documents you might want to prepare. I'll like basically introduce you to the Overleaf interface, so just different types of things you click on and set up, and how you can actually like experimentally like implement your own documents within a certain format. Whoops. We'll actually modify the LaTeX document. We'll like compile it, so it's a compile based thing. So you make your modifications, and then you press this like compile button, and it renders it. You can see how the document changes as a result, and then you can download it once you're satisfied with it. And then tables, equations, Bibtex references. Oh my, these things are kind of the trickier bits to LaTeX documents. They're not as user friendly as a what you see is what you get type editor would be. But there's like small trade-offs. Well, small. Some people might call them significant. My PI in particular is very much of a word guy. So there are trade-offs because these can be a bit more complicated to set up, but once they are done well, it looks beautiful. They end up like really turning out well. So without further ado, let's jump in. And just for the sake of like completeness, this is what like references would look like within a Bibtex, or like the Bibtex references. I'll show you what they actually look like when you implement them, but then you can just add them in. They would auto fill in. You just have to say like print the bibliography, and wherever a reference was set in the document, it will appear later on. So it kind of takes care of reference management as well, which is sometimes a really complex thing for other types of applications. So let me bring up. So here we'll just start off with an example. So what we're looking at here, actually, in a very like meta way, is the slide set, or like the slideshow that I had basically put together to introduce LaTeX. So this is what Overleaf, when you're creating a document, what it would look like. You have basically your like folders and files and images all here. So T1 for tutorial 1 LaTeX is this document here. If I wanted to look at something else like this style file, this other style file, there's a whole bunch of stuff in here. Every time you click on one of these, it brings it up as a new thing. General rule of thumb, style files, so .sty or class files, .cls, you'll never touch. If you modify something within there and break something, you'll probably have a really hard time fixing it back. So don't modify those. What you'll want to modify are these .tex files. So what this is basically, so there's like everything, all the tags in LaTeX are usually like preceded by a backslash, a certain key term. There are optional parameters that appear in square brackets, and then whatever types of options or the content themselves appear within these like curly braces. Usually at the beginning, like most programming languages, there's quite a few here because these are for like generating a presentation, and there's a lot of different like types of things like I like to use. You won't normally see all these things. We'll look at a simpler example after, but this is like importing libraries or importing things in any given like programming language, and you can also like set things up. So it's like, for example, if I want to use like hyperlinks or hyperreferences within my document, I can use this use package hyperref. I can define a color that I call rose with an RGB value of red, green, and blue, and I can say color the links. I want the link color to be rose, and I want the URL color to be rose. And that's why when you look at the color of these things themselves, I set those to be this like pinkish color. But you probably won't have to deal with much of this stuff. Really, you'll just worry about the content itself. So for example, so here I actually made an error. You'll have seen that T11 should actually be T1. I can modify that so it's tutorial 1. Here's the title. Here's some information about me, my institute, display the date. And then there's just like things that outline the slide. So there's usually this like begin document. So this is where the document actually starts. And then because this is a presentation view, it has these different like ways of representing different slides. So this is like one way to create a title page, which is this one. Then there's this like section header, who am I, a brief history of me, this like background. And then there's different ways to create lists. So I'll move on to I'll go through the gallery first, because this starts to become a bit more complex because it's more of a presentation style than an actual document, but it gives you an idea as to like the general format of this. Say I wanted to change the title, so Introduction to LaTeX, and I say, so here under title, here under the title, tutorial 1, say I change it to tutorial 3. This button here in green, when I say recompile, it's going to compile the document. It's going to grab everything, all the images, all the references. It's actually going to interpret everything, much like a compiled language, and generate it. So you can see we get this new title slide, tutorial 3 instead of tutorial 1. So any changes that you want to represent, you would have to like compile, and this is basically your PDF viewer as a result. If there are any issues or warnings as a result, you'll see them here. You can like look at the like raw log files as this document is being rendered itself. And if you want to download it, you can basically click this download PDF button. I could like set it to whatever, slide 3, sure, or slide 1. You can download it itself. And what we get then is, this updated version of the slide set with the one change that I made, in this case, tutorial 3, which I want to override back. So this is actually correct. But basically, it's like the way that you download everything. There's all these other things at the top too. What's beneficial is you can leave yourself comments. So it's like, say you're collaborating with someone, you can actually share this. So think of this kind of as also like a Google Docs, but Google Docs for LaTeX. You can actually have multiple people on the same. So if you're doing things with a partner, you can have multiple people looking at and modifying the same document at the same time, and you can like leave yourselves comments. So it's like, say I wanted to leave a comment for myself to make T1 not T3 because I'd want to change that back. I can leave this comment with a given timestamp, and other people can basically reply. Very similar, reply or resolve, very similar to what you would do in Google Docs, but only, again, for a LaTeX type document. You could share this. So say I wanted to share with collaborators or turn on link sharing. I can generate what these edit links or these view links. You basically just like copy those over and send them. Overleaf also integrates nicely with a lot of different journals. So if you want to use a given template for a certain type of research journal or a template for a conference, this is more like research related, but they've made it very easily to just like click a button to send it off, like very streamlined in certain fields like computer science, machine learning, and whatnot. For those of you that ever end up going on to doing research, perhaps. You can also look at the history. So like basically just a record of the changes over time. If you want to see, I basically copied the project over, deleted a bunch of stuff, edited this over the course of the last few hours, and then downloaded it. And if you want to go back and see what I did at 4:04 when looking this over, you can basically get the exact same setup, the exact same like tracked changes or like versioning of that document at that point in time. And then there's a chat. So again, if there are people, so I'm going to turn off this. Whoops. I don't want review one. Okay, so the chat itself, if there were multiple of us, I'd say things like, whoops, hello world, and anybody else on this chat or on this document would see this come up after the fact. But yeah, that's like basically it. Other things you might want to be aware of: you can create new files, you can create new folders, you can upload files. So say for images, so for example, there's like this images folder I created, and then within the images folder, there's this tutorial 1. So if I'm doing like multiple tutorials, I'll have like a T2, T3, T4, like subfolders within each. The only image that I used in this one was this Overleaf logo. Basically, I just in this T1 folder, you can do upload file. You just upload the file, and then you need to reference it within your document, and then it will basically appear. So very like convenient type of setups, very similar to what kind of Google Docs is like, but again, all for LaTeX. Let me just plug in my computer real quick before. And so that's basically general layout of this interface. This is also the title of the document I'm working on. So just like teaching winter 2021, SYSC 4906, so on and so forth. What you guys will want to do when you first start, you'll want to first create your account. So the first time you go to overleaf.com. You can create an account. It's free. It's a very, very nice system. And then you can go to this gallery. The gallery itself has basically templates, and I showed you an example of the template I actually made and submitted myself. But basically, it's just like a place where you can just explore different types of layouts of available things. So different things like academic journals. So maybe if you guys are going to apply for jobs or anything anytime soon, you can actually look at like resumes, look at some like really nice resume setups. You can basically create your own resume. There's like hundreds of these available. You can just kind of like work your way through, find one that you like. I don't know if you're more on this like design type layout. You can like download the PDF for each. Sure, I'll just do this because I want to like show. You can like open this up. You can get a good sense as to like how this like looks. I mean, this is like pretty nice-ish depending on the type of place you're applying to, and you can just kind of like copy or like replicate what other people have done before for like a 2-page resume with a nice I don't know, like general layout. So there, and then you'll notice there are a lot, so you can kind of like work through a number of different types of resumes that you find attractive or not. For example, as I showed, I created this one for an actual like publication I was working for. If you're working for an organization, as I say, you could probably try and create something along these lines that looks really nice, that makes the job a lot easier for people to put stuff together. But this is the one that we'll work through. So as soon as you like one, and this template might be the one that we use for this course as well, you can open it as a template. It will basically add it to your Overleaf account. And you can see this is all stuff that I've created before. Those from SYSC 4906 in the fall will remember this as the template that we used there. And it's like generally a simplified work that you can just change the title here for different authors. So if you guys are working in teams of 2, you would put your first name, last name, the department you're in, and so on and so forth, and your city. And then it abstracts away all the layout. So you don't actually have to worry about how the abstract, well, actually it's kind of a nice play on words. It abstracts out the layout, and in this abstract, all you have to do is like modify the content, and it will nicely lay it out here. You can add keywords. You can set different sections. Within each of these sections, you just write the text within each. So if we're like going kind of top down through the document, you can see that when we want to create a numbered list, we do this like begin, enumerate, and then set each of these items. You can zoom in to what that looks like here. So this is the first point of the list. This is what would be considered the second, and so on and so forth. And then there's all this like what is known as math mode, ways that you can represent mathematical variables or different types of things. Depending on the types of projects you work on, you may or may not need to, but there's convenient ways of representing mathematical equations that look particularly nice in LaTeX as opposed to other types of ways. So these like dollar signs, if I want to create this like mathematically stylized N, I wrap it in what becomes green in this case, math mode. This like underscore is used to basically create like subscripts. So that's this like X sub I. And then you can actually create these like numbered equations. So let me just zoom out a bit here. So if I want to like represent this like data set, so a data set made of n number of 2 tuples. So for those of you familiar with machine learning, like features of first example X, the class of example Y, and so on and so forth. So it's just like a data set made up of each of these, mathematically represented in this way, which is kind of a convenient way to put it. So there's these like bold symbols to make this data set, because it's a collection in bold. So this D, this like stylized D character, and then all this other information. And when we talk about equations, when you want to create an equation, whoops, I'll go here. There's this like convenient like code cogs type of setup. So if I want to create like E equals MC squared, it gives you all, it's kind of like a what you see is what you get, but for generating LaTeX basically equations. So here's like what E equals MC squared would look like. If I wanted to do something else as like a type of like fraction, I can basically click on this. This is the top part of the fraction, or like the numerator. I'll just say like, I don't know if we want like A over B, or A over B plus C, whatever it might be. Like that's the fraction. If I want to add that fraction to something raised, or say like a sum, I can click on this like sum character, or I can pick one of the sum characters that has this like above AB. So I choose the one that I like. This is the, again, the subscript of it. So whatever's underneath, so like n equals 0 up until the value of, say I wanted infinity. Anyways, you can like go and find different types of characters within these. Once you get a good hang of what these are, so there's the infinity character, so grab that. You get this like inf d. But basically, it's a nice way to just like represent these things. You would copy this over and paste it into your document as like LaTeX code, math code to be represented. You can also download it as a GIF thereafter. Just to like give an example. Oops. Control Z. Anyways, you can like copy that, bring it over, and then like render it within whatever document template you want here afterwards. And then if you want other things like tables, as I mentioned, are kind of complex to put together. I would suggest using this, go to like tablegenerator.com. So this as an example is just like an example table that I put together. Again, it's what you see is what you get. To create the table, you just type in whatever you want in these cells. Example header 1, some values of percentage, different values, model 1, yes, no, different types of things. Then all you do is click this generate button. So it must have updated this to add this header 1 to it. You just copy and paste this over. So it's just like copy to clipboard, paste it over, and it will appear the way that you need it to. And whoops, control, oops, Command Shift T. The other thing too is for the references, is like the last of the things I want to mention since we're kind of running out of time. This is what Bibtex references look like if you want to reference anything within your documents. One thing that you can do is go to, like say Google Scholar, say there's a certain paper that I want to reference. So say Donald Knuth, the textbook that describes the LaTeX system. You can click this like quotations button here, and one of the options that it gives you is basically Bibtex. So this is what you'll want to copy. So I copy this and add it to a template. You want to have this in a .bib file. So for like Bibtex, I don't know when the copy paste is not working in this case, but let me do this. Well, it only grabbed this one bit. Let me grab the whole thing. So this, copy, this. You want to grab the entire thing, paste. And then this is what's known as the key of the reference. So in this case, oops, let me copy that. And within the text itself, if you want to cite it, you can do something like this. One of the keys was cite as example. So here you would do something like / cite, curly braces, and then in this case, the Knuth 1984 textbook is what I want to add in. As soon as I recompile this, so I put this in the first paragraph of data and methods. So that should be this one here, reference 3. And if I go down, it automatically fills it in. So Donald Knuth's, the textbook, volume 3, exactly as it was set up in here with all its fields. So it takes care of all that, the reference management stuff itself. The last thing I'll touch on is just figures. So again, as I mentioned, if you wanted to upload a figure, you would use this like upload file. This is this is a PDF figure. So you can upload different types of PNG, a PDF, an SVG, whatever it might be. And then whenever you want to insert a figure, you would use something along these lines, like begin figure. I want it to appear at the top. I want it to be centered on the page. You put this like include graphics in. I want the width to be 30% of what is the full text width. So if I change this to say 50% with a certain caption, I'll just add in like hello world here with a certain label so that you can refer to that figure in the text. I think later on or somewhere around here, I say, here I reference a table. So each table has a label. You can also reference the figures, although I don't know where exactly I do that in this case. But anyways, as soon as I recompile this, because I made it 50% instead, this is going to get a lot bigger. So now it's 50% the width of the page. So you can kind of like toy around with how it's laid out and like change a number of things. But basically you end up then with just this like very well like displayed document within, in this case, just like what is like 100 and some lines of text, where all you need to do is just make sure you put in the right kind of tags and like formatting. Whoops. And there's a huge number, like there's a large community behind LaTeX as well. So as soon as you run into any kinds of issues, whatever it is you're trying to set up, there's basically a very like good explanation on Google usually to help you like basically figure out what you're trying to do. So things like mathematical symbols, like what if I want the greater than or equals to sign? Well, if you type in what is the greater than or equals to symbol in LaTeX, you'll get this like \GEQ. So this is like greater than or equal to 300, wherever that does appear in the document. But yeah, so right here, so example greater than or equal to 300, and so on and so forth. So yeah, this is like kind of the general introduction. I think the more that you get a handle on using these things and actually learning what the tags are and how they work together, you'll get a good sense for how you can use this for a number of different types of applications. I hope that this is more or less straightforward. We kind of pushed time, so this is getting on to like 50 some minutes. If there are any questions that you guys have, or if we're going to need a follow-up, maybe like a bit of a deeper dive into more of the tags and more of the type of markup that you need. Let's see what the professor thinks about all that, and we'll put that together. So yeah, other than that, good luck. I'd hope that you guys start getting a good handle on how LaTeX can be used in a number of different ways. And I'll probably see some of you at some point later on in the course. So yeah, good luck and all the best. And